All right, in this video, we are going to work through the following problem. It says if the sine of t is equal to 3/8 and t is in the second quadrant, find the cosine of t. All right, so the first thing that you want to do here is just draw a little sketch of what the angle looks like. So and I probably didn't leave enough room, but yeah, let me erase that. Okay, so here is some coordinate axes, and I want to draw the angle t, right? An angle in standard position, right? So remember that means that the vertex is at the origin, the initial side points in the positive x direction, and so the terminal side is up in the second quadrant, right? So it would be somewhere up here. And remember the sine and cosine of this, or cosine and sine, are a point, right, on this terminal side. It's the point where the terminal side meets the unit circle, okay? So at some point on here, that's all we really need for this, right? And so we know that that point up here is in the second quadrant, right? So if a point is up here in the second quadrant, that means you would have to go in the negative x direction to get to it, and in the positive y direction. So it's going to be a negative, right, and then a positive, like so. All right? And so what that means in terms of the sine and cosine, that means that the cosine is going to be a negative number and the sine of t is going to be a positive number, which we already knew, right? But we are finding the cosine. We need to know whether it's positive or negative. So now we know, hey, it's going to be a negative number, okay? And that's going to be important later on. All right, so we know the sine. We want to find the cosine. So what we can do is one way to do it, and there are multiple ways to do this. But the way that I'm going to do it is I am going to use the fundamental Pythagorean theorem that says if I have any real number t, right, any angle, the sine squared plus the cosine squared equals 1, or however you want to write it. All right, and so that is the identity that we're going to use. And we already know that the sine is 3/8, so this part of it is going to be 3/8 quantity squared, like that. All right, and we are going to want to solve for the cosine. Okay, so now what we're going to do then is get cosine squared by itself on one side of the equation. So in order to do that, I'm going to simplify both sides, and then I am going to add or subtract, right, to get cosine squared by itself. All right, I'm going to write it a little over the side to save some room. All right, so first thing is I'm going to start simplifying this left-hand side. I have 3/8 squared, right? So that'd be 3/8 times 3/8. The way that you would do that is just to square the top and square the bottom, right? And that's equal to 1. And I know that 3 squared is 9. 8 squared is 64. All right, so I have each side about as simple as I can get it. And so now what I want to do is add or subtract from both sides with the goal of getting cosine squared by itself on one side of the equation. So what I'm going to do is subtract 9/64, right, from both sides. So over here on the left-hand side, 9/64 minus 9/64 is 0. That's going to leave me with just cosine squared t over here on this side. And then I have to do this subtracting fractions here, 1 minus 9/64. So what I need to do is to write 1 with a denominator of 64. That way 1, right, and 9/64 are going to have the same denominator. In order to combine or subtract two fractions, right, they have to have the same denominator. And so writing 1 as 64 would just be 64 over 64, okay? 64 divided by 64 is equal to 1. So these things are equal. So now instead of doing 1 minus 9/64, I can do 64 minus 9. 64 minus 9/64. They have a common denominator, right? So all I would do is subtract the numerator. 64 minus 9 is 55. All right, and then I would keep that over the same denominator. Right, because that's how you subtract fractions. You subtract with common denominator, you subtract the numerators, keep it over the same denominator. All right, so now we have cosine squared by itself on one side of the equation, right? And so now we can use the square root property to solve for cosine, right? You can kind of think of that as taking the square root of both sides. The one thing that you cannot forget, right, is that you have to put this plus or minus here, right? There are two solutions, as long as this number is positive, there are two solutions to this equation, one that's positive and one that's negative, right? And so the solutions are going to be plus or minus the square root of 55/64. Okay? All right, so now I've solved for cosine t. The only thing I have left to do is to pick which one I'm going to use, right? Either the plus or the minus. We've already hashed that out back up here, right? We know that we are after the cosine, and we already have worked out that if this is a second quadrant angle, then the cosine has to be negative, right? The cosine would be the first coordinate of this point, which is negative. Okay, so based on that analysis that we did before, right, we know that cosine of t is equal to negative square root 55/64. Okay, so the rest of what we have to do is just to simplify that expression over here on the right as much as possible. One of the rules for simplifying radical expressions like this is that you do not want to leave fractions underneath the radical. So if I have a fraction, the square root of a fraction, right, is going to be the square root of the top over the square root of the bottom, like so. And then I'm going to simplify these radicals as much as I can. All right, 64, right, is a perfect square. So we know that the square root of 64 is 8. So that one's good. And now that just leaves us to figure out how to reduce this radical here. So it's 55, right? If you look at 55, right, it's 5 times 11, right? It's prime factorization. And so what that means is that you are not going to be able to reduce this, right? There's no perfect square that's going to go into 55 evenly, right? If you look at 4, does 4 go into here? Nope, it's not going to go in, right? Does 9 go in? Nope. 16? Nope. 25? Nope. None of those numbers go in evenly. 36, 49, right? And so you're not going to be able to reduce this. And so this is it. This is the final answer on this problem. Negative square root 55/8.